Just some housekeeping to start off with. I have a terrible habit of saying and so if I do that, I would like to be stopped, and I'm going to put this at the beginning of my slides until I stop doing it in every future presentation. Question both individuals and companies like to ask is, should I invest my money in this stock? In other words, can we predict future stock prices? History doesn't repeat itself. History doesn't repeat itself, but it rhymes. So let's start by looking at the history of the stock price. We're going to take Amazon from a 9-year period, 2006 to 2015. And the data is in a CSV spreadsheet. And it looks like this. We're only interested in the date and the closing stock price over that 9-year period. And in engineering, old advice says, do the simplest thing that could possibly work. So with very little knowledge, I think it makes sense to start off with the recurrent neural network. And this solution is given at this URL, and I'm going to walk you through it from first principles. This solution is given here, and I'm going to walk you through it from scratch. From a very good investing book by Benjamin Graham, it says, in the short run, the market is a voting machine, but in the long run, it's a weighing machine. In other words, in the short term, stocks are very subject to human evaluation, subjective human evaluation. In the long term, they tend to converge on where the stock should truly be valued at objectively. I heard the terms long term and short term. We actually have a type of recurrent neural network for that called long short-term memory. This was developed in 1997 by a couple of researchers in Germany and Switzerland. So using this type of model, how can we write some Python code that will help us predict prices of the Amazon stock? Code is very simple here. And we have a few input parameters, which you'll see graphically in so far as they matter. And when we run the model, it will take a bit of time to do all its number crunching, pattern recognition, backpropagation, etc. And given that it's a recurrent network where the price at time t plus 1 is dependent on time t, or t minus 1, we cannot parallelize much with GPUs. So it's 40 seconds of training. What we find is that the majority of the training takes place in the first 20 epochs, and by the time it gets to 40, we've almost learnt as much as we can. Using LSTM, this is what we end up with. The red part projects out the predicted stock price given the past data that we have here in green. But is this correct? Let's see what the actual stock price was, which is going to be shown in green, extending past where we currently have green. Well, before we get that, do you think this is correct? To me, it looks correct. The slope is vaguely going upwards at the same rate. There's some random variation, but it looks correct. Or does it? That is the actual price of the stock from Amazon, which has been known to do very well. So LSTM did not perform that well, I think it's safe to say. Staying with recurrent neural networks though, let's try another one. GRU instead of LSTM. Now, GRU stands for Goats Randomly Unleashed. I'm just kidding, just trying to check who's paying attention. Stands for Gated Recurrent Unit. So in fact, there are still gates, just no goats. You might ask yourself, why would this be any better? Is this just not going to be a failure for the same reason? Well, it could be, but let's just try it first and then see what happens, and then see what we can learn from that. So again, code is very minimal. We're only changing a few things. The general shape of the code is going to be the same. This is what we had before, a very big divergence between the predicted and the actual stock prices during the years 2016 and 2017. This is what GRU, Gated Recurrent Unit, looks like. Now that looks a lot better. It's not perfect, but it's a lot better. You might still be asking, yes, it's better, but why would it be better? It makes some sense to look at the mechanics of the two recurrent neural networks. And we're not going to get into the mathematics, but the key point here is that LSTM, to obtain its longer short-term memory, it has gates that control it. And it's relatively it's more complex in how it decides what to keep and what to throw away when trying to make future projections. GRU, on the other hand, is a simpler type of neuron, and it only uses one calculation that somehow balances between short-term and long-term. So just thinking back as we learn, what is it about this model that makes it good or bad? These are what we can conclude. LSTM, it's prone to overfitting. And with noisy stock market data, because it's subject to a lot of human emotion, you see a lot of wrong patterns and make wrong predictions that may work fine on a training set, but they don't generalize well to test data. GRU, on the other hand, has this inbuilt recency bias, which humans in general are subjected to, and the stock market prices are, in the short term, subjected to, as our friend Benjamin Graham said. So it makes sense. GRU is a short and medium term, but not so much long term. And we saw that the accuracy, if we were to quantify it, goes from 335 squared error to just 39. So that's almost that's a tenfold improvement. What I've not covered here is whether this works well on other stocks, and that would require more time and analysis with other data that is provided in the Kaggle dataset. But apart from that, you can see that it's quite easy. The code is short. The intuition is simple. And the hard part is, as a human, deciding what to do. And that has to be a stakeholder's decision. That is not decided by the computer model.